Good everyone, my name is Graphics. Today we want to study an aspect of mechanical engineering science, which is what? The graphical analysis of resultant force. We can always analyze resultant force using analytic method, or we can use graphical method. But today we want to use the graphical way to what? Analyze this question. He said calculate for the resultant force for the following coplanar force, which is 150 Newton at 78 degree, 280 Newton at 143 degree, 485 Newton at 2493 degree, 98 Newton at 305 degree, 215 Newton at 84 degree. Now the first thing you have to do, you need to draw a scale because you want to analyze it graphically. So you need to put what? A scale. And the scale you should be putting on so that you'll be converting the Newton into what? Into millimeter, in order for you to measure it on what? On your meter rule. So we know very well that if I say let 1 Newton be equals to what? 0.2 millimeter, right? So I'm taking the first one. 150 Newton will be equals to what? 150 multiplied by what? 0.2 millimeter, and this will give us 100. That will give us 30 millimeter. When you multiply 150 by 0.2, you have what? 30 millimeter. So this is what I'm having here. So what I'm going to do here actually is that I'm going to measure 30 millimeter, and I'll go like this. So let's see how it goes. So from here, I'm considering 150 at an angle of what? 78 degree. So I'm going to place my meter rule this way at this point. Let's take it at this point. I'll measure my 4 cardinal points like this, here. So I'm assuming I'm taking this. So I'm having this and also this. This is my north, this is my south, this is my east, and this is what? My west. So we're moving from 0 degree on our north axis, and we're going this direction clockwise, right? So we know the force is 150 Newton and the angle is what? 78 degree, right? So that's for the first one, 150 to what? 78 degrees. So I'll measure 78 degree here. I'll take my protractor and I'll place it at this point. Let's see what it goes. So if I zoom this, I will ensure that this cross here is falling on the center here. Can you see? So I'm assuming that this vertical point here is uniform to my knot here. So that is 0, 90, 0, 10, 20, 30, 40, 50, 60, 70, then 78 will be this, 75, 76, 77, 78 will be here, right? So that is the point. I am going to draw my line from this center here. So now I'll use a faint line first because I'm not sure. Can you see that? And I'll measure 30 millimeter on this line. So with the help of my meter rule, I'll place it here from 1. I'm starting from 1. So 1, this is 0, 10, 20, 30. And this will stop at 4. So I'm now taking it from this point to this point. So the angle from here to here is 78 degree, right? And this we're having the magnitude is what? 150 Newton. that is 150 Newton. Right, so we're moving forward. At the same point that I stopped here, which is my 30 millimeter, I'm going to come here also. I will draw my 4 cardinal points. I'm going to draw my 4 cardinal points at this point. You can place your 14 here to ensure the line is straight. You can see my line of 14. This is here, so I'm going to do this. So and I'll do here too. 4 cardinal points here. So from here, let's straighten that guide very well. So we straighten it from here. That's what to do. That's right, like this. So this is my north, this is my south, this is my east, and this is what? My west. Now, if you check the other one, the other one is telling me 280 Newton to what? To 143 degree. So for 280 Newton, in bracket, 143 degree, I'm going to do my scale again. I will say 1 Newton equals to what? 0.2 millimeter. Then 280 Newton will be equals to 280 multiplied by 0.2, and that will give us 56 millimeter. So on this scale, we know this our vertical part is 0 degree, here is 90, right? And we're looking for 143 degree. So at this point here, we'll measure the 143 degree. So the 143 degree, we know from here to here is 90, from here to here is 180. We know 143 degree falls within this domain. So what I will do is I will take my meter rule, my protractor. I will ensure that it is on the same line like this, right? So this horizontal will be my what? My 0. So if I'm moving, we're talking about 280, right? 143. So this will be 90. Our 0 is 90, right? 100, 110, 120, 130, 140, and 143 will be here, right? So that is the 143, and I'll place it from here. Use my faint line first to connect the center of this to here, right? Connect it there. So from that point, I know this is 156. I know this is what? 56. So I'm going to measure 56 from this point. I'll measure 56 on here, and that will be, I'll measure 56. So this is 0, 10, right? 20, 30, 40, 50, 56 is here. So I'm going to draw my line to pass from here to kill it. That is 56. So the angle from here straight down to this point is 143 degree. Are we good? So from there, at this end point, I know this line, the magnitude of this line is 280 Newton, right? So I'm going to draw my 4 cardinal points at this point also. I'm going to have this horizontal and vertical also. This is my vertical here. This will be north, south, east, and west. So now we'll do the same thing here. We want to get the next one, and the next one is this. Let's look at it, which is 485 at an angle of what? 249 degree. So we are doing that now. 485 at an angle of 249 degree. so I'm going to do it here. So the next one is 485 Newton at an angle of what? 249 degree. So we'll do the same scale. We'll say 1 Newton is equals to 0.2 millimeter. If you can change this, you can change the unit, but the bigger it is, the bigger your graph, right? And you won't be able to draw this easily on your sheet. So I'm taking this. This is a minimum point you can take. You can even take 0.1, but it will be too small. So 1 Newton is equal to 0.2 millimeter. So 485 Newton will be equal to what? 0.2 multiplied by what? 485. 0.2 multiplied by 485 is, we have 97 millimeter. Right? So what I'll do first, from this angle, I'm going to measure 249 degree first. So this is 0, this is 90, this is 180, and this is what? 270. So 249 falls between here. So what I'll do is, I'm going to take my meter rule, I'll place it like this, right? Ensure that it is conforming with my north and south, right? So if I do that, I want to measure 249. So measuring my 249, I'll start. This is 0, 90, 180. So 0.0 here is 180, 190, 200, 210, 220, 230, 240. Then 249 is somewhere around here. Is this 249, right? So that is the point I need to draw from. So the length of it is 97. So from this point, I'm going to measure 97. So I will allow my number, my 97 should be here. So from this is 97. From here, this is my 97 here. Right? So this is 97 here. So passing through the center here. So if you calculate it, this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 95, then what? 97. I'm going to draw a line that will pass through that point, follow the point and stop at here. So that will be the magnitude of what? 485 Newton. 485 what? Newton. So the angle from here straight back to this point here is what? 249 degree. 249 degree. So after that, at the same point also, I'm going to draw my 4 cardinal point also. So I'm going to do this. So this will be vertical, and this will be horizontal. Here will be north, south, east, and west. So now I want to consider the next one, which is 98 Newton to, look at it here. The next one is 98 Newton to 305 degree. So we'll go there and do that. 98 Newton to 305 degree. So I'll do it here for 98 Newton to 305 degree. So if I say 1 Newton is equal to 0.2 millimeter, then 98 Newton is equal to what? 0.2 multiplied by what? 98, right? So that will give us 0.2 multiplied by 98 will be, we have 19.6 millimeter, right? So at this point here, before I move, I must go 305 degrees. So let's, from here, this is 0, this is 90, 180, 270. So 305 is between north and west here. So I'll take my French curve, my protractor, and I'm going to measure now. So in measuring, I can place it this way if I want to. right? So I place it this way. Ensure that this line is conforming between east and west. So since this is 270, I'm looking for 305. So 270 is 0, 280, 270 is 0, and this is 280, 290, 300, 305 is at the center here, right? So I'll take my meter rule and pass it through there, but I'm going to measure what? 19.6. So with the center here, and now I'm going from this point to this point. I'll use my faint line by pencil first, from this point to this point. So I'll use my pencil from here to this point, right? I'll measure 19.6 there. This is approximately 20. So if I start from 13, if I start from 13 here, which is this, 13, that will be 0, then 20, so 19 to be here, 19.6 approximately. So I'm going to draw it from here and stop here, is what I need. So my magnitude here is 98 Newton, right? So that means from here to this point here is 305 degrees. Now on that same point again, I'm going to draw my 4 cardinal points. Also, I'll draw north, come here, and I'll draw west. So this will be my north, my south, my east, and my west. Now if you look at the last guy there, we have is 215 Newton to what? 84 degrees. Look at it very well. We have 215 Newton to what? 84 degrees. So I'm going to come and write this out. I say okay. I have for 215 Newton towards 84 degrees. My scale is saying 1 Newton is equal to 0.2 millimeter. Then 215 Newton will be equal to what? 0.2 times 215. So and that will give us so this will give us 43 millimeter. So first of all, I'm looking for 84 degrees. Now we know from north and east is 90, so 84 falls in between those two. So I'm going to take my protractor, place it at that point. This my line here will be at the same point. Can you see that? So I will measure my, let me show you. I'm going to measure that. So ensure that it is well placed. I've done that. So that will be 0 is my 90, 10, 20, 30, 40, 50, 60, 70, 80, 84 will be somewhere around here. 84 here. So I'm going to draw my lines from here, faint lines first, because I'm not really sure about the length. So from this point here, I draw my line, faint line. Can you see? So I'm going to now measure 43 millimeter. So measuring 43, I'll start from this point. This will be 0, 10, 20, 30, 43. So I'm going to take in it from this point to this point. So we know very well that from here to here is what? 84 degrees. So this is where I'm stopping here. So at this point, my resultant force will be the distance between this final position. Let me show you. My resultant force will be the distance. I can just draw my 4 cardinal points if I want to. This and then this and this. This is north, south, east, and west. So my resultant force will be the force that is connecting this last position here to the initial position. So from here to here will be what? My resultant force, R. Right? I'm going to measure the arrow from here to here. So if you are measuring that arrow from this point, let's say my 1 is my 0 here. So I will say 0, 10, 20, 30, 40, 50, and 59. So that is 59. So if you say the resultant force is equal to what? 59 millimeter. So if you divide it by 0.2 to convert it to Newton, are you with me? So 1 Newton will now be equals to what? 59 divided by what? 0.2, and that will give us what? That will give us 295 Newton. So my resultant force here is what? 295 Newton. So you had as the case here now, 59 millimeter. 59 millimeter is equals to what? 59 divided by 0.2 Newton. Right? My resultant force here is what? 295 Newton. So if you have found this video helpful, don't forget to click on the subscribe button for more videos. Thank you very much.